Good morning, boys and girls. Welcome to another lesson on physical sciences, grade 12. It is the National Tutoring Campaign, and we are preparing you for your preparatory examinations as well as your final examinations at the end of the year. I hope that you are ready for me, and please make sure that you have a pen and paper so that you are able to take down the notes as well as answer the questions with me so that this becomes a learning curve. Right. Without wasting any time, note that today we are going to look at organic reactions. In the previous week, we looked at nomenclature. Now, this section, once more, it's very important because it counts a lot of marks. Organic chemistry on its own, it's 48 to 60 marks. And this section can be about 18 to 20 marks. So I want you to be well vested in it and be ready to get a total. Right, we move on. Now, you should be having examination guidelines, and preferably you should be having the 2021 examination guidelines for physical sciences. And if you have those examination guidelines, you will see that the examination guidelines are very clear about what you should know about every topic and every section of a given topic. In terms of organic reactions, what we are required to know is we must be able to work with the oxidation of alkanes. That is to state the use of alkanes as fuels, and also we must be able to write down an equation for the combustion of an alkane in excess oxygen. So that is that with regards to alkanes. Furthermore, what we should be able to do is to deal with the type of reaction that we call esterification. And this is where you must be able to write down an equation using structural formulae or a condensed structural formulae to show how an ester is formed. Also, from the ester that has been formed, you must be able to identify the alcohol that was used as well as the carboxylic acid that was used to make that ester in the first place. And also the conditions that are required in order for an ester to form, in order for an alcohol and a carboxylic acid to react. And we will remember those conditions are that you need heat and you need sulfuric acid as a catalyst. Now, with more reactions, once more, we have substitution, we have addition, and we have elimination reactions. And when we are given a reaction, we must then be able to identify that reaction as either substitution or addition or elimination. Again, we must be able to write down those reactions, either addition, either substitution, or either elimination using structural formulae, and also using condensed structural formulae. And remember, we must know the conditions for every type of reaction. Now, here we have different types of addition reactions that we must know. Our hydrohalogenation, halogenation, hydration, as well as hydrogenation. All these we need to know. And also, we must be able to identify the major and minor products in the above addition reactions. And we'll talk about that when we start to talk about the rule for addition, right? Furthermore, according to the examination guidelines, it tells us that we must be able to deal with elimination reactions. And the type of elimination reactions that we must be able to work with, it's dehydrohalogenation as well as dehydration. So these are two types of elimination reactions that we must be able to deal with. And furthermore, we must be able to deal with the type of reaction which is elimination, but that follows the process of cracking when we deal with alkanes. Talk about that. Furthermore, when we perform elimination, just like with addition, we must be able to identify the major as well as the minor products for elimination reactions. Furthermore, we are going to look at reactions of haloalkanes. When we deal with haloalkanes, we are going to look at the hydrolysis of haloalkanes. And that is when it is a haloalkane that is reacting with water. And then we will also look at the halogenation of alkanes. And this basically refers to substitution. So this is very important altogether. And this is essentially what you need to know when you are dealing with organic reactions. Remember, for 2021, and just for 2021, you are no longer dealing with polymerization reactions, and hence it is very important that you get the latest version of examination guidelines, which are the 2021 examination guidelines, because those ones you will see that the section on polymerization reactions has been removed because it is no longer part of the syllabus. So I'm advising you, make sure that you have those 2021 examination guidelines. If not, ask them from your teacher. Now, we move straight to questions. Now, it reads as follows. Ethene is a gaseous hormone associated with the ripening of fruit. Now we know what ethene is. It's a molecule that we get in the homologous series alkenes. Now, they tell us it contributes to the aging and distortion of plants. In industry, the artificial ripening of fruit takes place when ethene is passed over the fruit in large rooms. After a while, the ripening fruit releases its own ethene. So here they're telling us about the important use of ethene, and that use is that artificially it can be used to ripen fruit, and that happens in large rooms in the industry, and after they run ethene in those large rooms, then the fruit will then release its own ethene. First question says, write down the structural formula of ethene. Now, when we want the structural formula of ethene, we are going to examine the name. The name begins with F, and the name ends with ENE, right? Now, we know if it begins with F, it simply means that the number of carbon atoms, it must be 2 of them, right? So I will draw, this is now the answer here. F means 1, 2. And then Ene means this molecule belongs to alkenes. Now, if it belongs to alkenes, we know that the functional group of alkenes is a double bond between carbon atoms. And there's the double bond between carbon atoms. And the only thing that is left is to put my hydrogens and make sure that around each carbon, I only have 4 bonds. So on this very first carbon, I have 1, 2. So I'm going to put the third one, and I'm going to put the fourth one. There's my H, and there is my H. Then on the other carbon as well, I need to make sure that it has 4 bonds. So already it has 1, 2. So to put the fourth one, the third one, I will put an H there, and then I will put an H there. And therefore, I have 4 bonds around each carbon. 1, 2, 3, 4. 1, 2, 3, 4. And this is the structural formula of ethene. And this is definitely 1 mark for the functional group being correct, and another mark for the whole structure being correct. Then we go to 34.2. They ask us, why is it not advisable to place a banana that has been artificially ripened alongside a cabbage and lettuce? Now, let us think about this one. If I take a banana that has been artificially ripened, I've been told that after I have artificially ripened it, then it is going to release its own ethene. It means that if I were to place that banana next to a cabbage and lettuce, then when that banana releases its own ethene, then that ethene would cause the cabbage and the lettuce to ripen. And obviously now, when the cabbage and the lettuce ripens, it means that the cabbage and the lettuce is going to become soft. And that is not how we want our cabbage to be. We want the texture of our cabbage to be a little bit hard, to be crunchy. So it is not advisable to then place a banana that has been artificially ripened next to cabbage and lettuce, because it will release its own ethene and it will cause the cabbage and the lettuce to ripen, making it soft. And that is not the ideal texture. So the answer then should be the banana will release its own ethene the banana will release its own ethene. Which will cause the cabbage and the lettuce to ripen, right? Oh, it will cause the cabbage and lettuce to ripen. Right. And therefore making it soft. There we go. That one didn't look nice. To ripen and soften. That is essentially not what you want. You want your cabbage and lettuce to be crunchy, right? And that should give you 2 marks. Then we go to the next question. They tell us, in industry, ethene is also used to synthesize a variety of organic compounds. The flow diagram below illustrates some of the many reactions ethene undergoes. Now, here I've been given a flow diagram, and you must be expecting that the questions for organic reactions are going to come in the form of a flow diagram. And you are required to interpret the flow diagram. Right. As you interpret the flow diagram will have omissions, meaning there will be molecules that have not been shown, but also there will be molecules that are shown, as we can see on this particular flow diagram. And therefore, it becomes essential that you do not think of a flow diagram as a complete diagram. You must think of a flow diagram as how the reaction is undergoing, but also are there molecules that have not been shown, but as well as any molecules that have been shown. Do we have reactants that have been shown and reactants that have not been shown? We have products that have been shown and we have products that have not been shown. Now, the best thing to do when you approach a flow diagram on organic reactions is to actually write down these reactions as you see them. And when you go to the answers, it will be easy for you to interpret them. But that obviously will require you to be fast enough. Now, we are going to go straight to the questions and look at what is being asked about this particular flow diagram. Now, the first question on the flow diagram asks us, write down the general formula for the homologous series to which ethene belongs. So we want the general formula to which ethene belongs. Remember, this one is a recall question. You must know the general formula of each and every homologous series. And you need to know it off by heart. If you don't know it off by heart, you must be able to look at the molecule and determine its general formula. But the general formula, using recall, we know that it's CnH2n. And that alone is going to give you 1 mark. Then we go to 34.3.2. They say, name the type of reaction represented by each of the letters A, B, D, and H. So we are going to write down the type of reactions by A, B, D, and H. Now we are being instructed, write down the letters A, B, D, and H, and next to each, the type of reaction. Right. So let us look at A, let us look at B, let us look at D, and let us look at H. If you look at ethane, ethane looks like this. There's 2 carbons because it's F, and A means it's an alkane. So I must have single bonds between carbon atoms and make sure that around each carbon atom, I have 4 bonds, which is what I have done there. And then I put my hydrogens. There's my hydrogen. There's my hydrogen. So this is ethane. And then we must draw bromoethane. If you look at bromoethane looks like this. The F means 2 carbons, 1, 2. Right? And then the A means that it is a form of alkane, and the bromo obviously now tells us it is a haloalkane. So single bonds between carbon atoms, and then I know that I have a bromine. Now, because I have a bromine, I can put the bromine anywhere that I want because it's a functional group. And if I put it on this carbon on the left, it means the carbon on the left is the first carbon. If I put it on the carbon on the right, it means the carbon on the right is the first carbon. So it does not matter on which carbon I'm going to put it. So this looks like bromoethane. In fact, it is bromoethane. So they want to know the type of reaction that took place. So we can see this is how ethane is, and this is how bromoethane is. And therefore, we can see that in this place where there was H, it is now a bromide, and everything else is the same. It means this hydrogen here has been substituted by a bromine, and therefore the type of reaction by A is definitely substitution. Right, it is substitution. Right. Then let us look at B. B, we take ethene. Now let us look at ethene. Ethene looks like this. We've already drawn it. 2 carbons, double bond between the carbon atoms. Right? Each carbon must have 4 bonds. Right? 1, 2, 3, 4, 1, 2, 3, 4. Right? There is ethene. And then this ethene has now been converted to ethane. So what we can see for B is that I started with a double bond, and the double bond has been broken. And we know when we break the double bond and we form a product with single bonds, then the type of reaction is definitely addition. Right. The type of reaction is definitely addition. Right? Then let us look at D. If you look at D, we have ethanol going to ethene. So let us draw ethanol. F means 2 carbon atoms. 1, 2. The all means it's an alcohol, so I must have an OH. There's my OH. Right. Right, so there we have ethanol. And the OH, it can go to any carbon atom. Why can it go to any carbon atom? Because if it's on the carbon that is on the right, most definitely, my dear learners, the carbon on the right, like this one, becomes the first carbon. If it is on the left, then if the OH is on the left, then the carbon on the left becomes the first carbon. So it doesn't matter on which carbon we take it. So the transformation that we see is that ethanol, which is this one, has been converted to that one, which is ethene. So I started with single bonds between carbon atoms, and now I have formed a double bond between carbon atoms. It means the type of reaction that I performed here is definitely elimination. Right. How else do I see that it's elimination? Because there I had an OH. I had an OH and I also had an H. But when you come to ethene, the OH and the H is gone. It means they have been eliminated. Then let us look at H. H, we take ethanol. There's ethanol. And this ethanol changes to bromoethane. Now, when it changes to bromoethane, remember, bromoethane still can look like this, right? Just want you not to be confused. Right. I just do this. And I do this. Right. You will agree with me that this is still bromoethane. And what you then pick up, my dear learners, is that where you had a BR, rather, where you had an OH, you now have a BR. Everything else here is the same. Everything else here is the same. The BR and the OH are what is not the same. And it means this OH has now been substituted with the BR. And the type of reaction for H will then be substitution. Right? It will then be substitution. Right, we go further. We have answered that, and there we have our 4 marks. Now, the next question says, use structural formulae to write down a balanced equation for reaction B. So we want to write down a balanced equation for reaction B. Now, reaction B, that is when ethene forms ethane. So we must use structural formulae. So it means ethene is my reactant, ethane is my product. Why? Because ethene is the one that is reacting, and ethane, it is what is going to be produced. So when we write the balanced chemical equation, on the left-hand side of the arrow, that is where I put my reactants. So I have a carbon and I have a carbon, double bond. Remember, this is ethene. This is ethene, right? 2 carbons, double bond between the carbon atoms. We make sure that around each carbon, we have 4 bonds. Then ethene is being converted to ethane. It means ethane is the product. So F, it means I still have 2 carbon atoms. Now, when I have 2 carbon atoms, the part where it says ane tells me that I'm only dealing with an alkane. So I'm expecting to have single bonds between carbon atoms. And then I make sure that around each carbon atom, I have 4 bonds. There we go. Right. Now, what we should be able to see is that there has been a transformation. Now, what is the transformation here, my dear learners? The transformation is that now it shows that I have an H that was added there. I have an H that was added there. Now, these 2 hydrogens that were added there were not shown in the flow diagram. It means there was another reactant that is missing, and therefore this must have been plus H2. And from that, you can see that our reaction becomes balanced because the number of carbons on the left is 2, and the number of carbons on the right-hand side is also 2. The number of hydrogens on the left is 6, and the number of hydrogens on the right-hand side is also 6. There we can see it. So our chemical reaction is balanced. But remember now, my dear learners, once it is balanced, I always deal with this method with organic reactions, RCP. It means I must show my reactants, I must show the conditions, and I must show the product. It means all the time, think about RCP, reactant, conditions, as well as products. And the condition that must be met here is that you must use either platinum, or you can use palladium, or you can use nickel as a catalyst. And this is essentially what they asked you. So you'll get 1, 2, 3, 4 marks. Even if you just write any of those particular catalysts, then you have made sure that all your reactants are there, your products are there, as well as the conditions, and you have also made sure that it is chemically balanced, meaning the number of carbons on the left is equal to the number of carbons on the right, and the number of hydrogens on the left is equal to the number of hydrogens on the right. And that's how we do it using structural formulae. Then they ask us, apart from ethene, in other words, except ethene, which other reactant is needed for reaction F? Write down the formula only. So they want the formula. It means they don't want the name. So we must give them the other reactant that is needed for reaction F. Right. Now, if you look at reaction F, you have ethene, and ethene forms bromoethane. Now, let us examine it. So, reaction F, we have ethene. Okay, that didn't look nice. There we go. There's our ethene. There's our ethene. So you don't cut corners. You work on it. You try and understand the transformation. So ethene was the reactant, and it formed bromoethane. It means bromoethane is the product, right? We have already drawn bromoethane. We know how to do that. There's bromoethane. Good. Now, let us look at the transformation here, my dear learners. You should be able to see that now all of a sudden there is a hydrogen in the product on that carbon and the bromine on that carbon. It means this hydrogen and this bromine were added because at those 2 points, they were never there altogether. So it means this flowchart was incomplete. They did not show me the other reactant, and hence it is my duty to determine the other reactant. And because I added an H and a Br, it means the other reactant must have been HBr. So when you use HBr, then you see that the number of carbons, hydrogens, and bromine atoms in the reactants is equal to the number of carbons, hydrogens, and bromine atoms in the products. And therefore, the answer must be HBr. And there you will get a mark. And this HBr, it is inorganic. Why? Because this molecule does not contain carbon atoms altogether. So note that from the flow chart, my dear learners, not all the reactants are going to be shown and not all the products are going to be shown. It becomes your duty to ensure that you work them out, right? Then 34.3.5, both reactions E and G occur in the presence of a base. Now we know from our theory that reactions that occur in the presence of a base are the reactions of haloalkanes. And we know that the reactions of haloalkanes, they will either undergo substitution or they will undergo elimination. Now they tell us reaction E is an elimination reaction and reaction G is a substitution reaction. So now they tell us that reaction E, which is this one, bromoethane to ethene, they tell us that this one is elimination, right? And they tell us that reaction G is substitution, right? And definitely can agree with E that it is elimination, because check, there you had bromoethane and it forms ethene. The H and the Br go away, so they've been eliminated. Bromoethane to ethanol, it is definitely substitution. Why? Because where you had the Br, it has now been substituted with an OH. So we can see that in both reactions, E, bromoethane to ethene, bromoethane to ethanol, those are reactions of haloalkanes. Now they ask us, how is the base in reaction E different from the base in reaction G? Remember, for elimination, the base must be a concentrated strong base. It must be a concentrated strong base. Why? Because this is for elimination. Right, so you will use a strong base, but it must have a high concentration. And for reaction G, my dear learners, It is substitution, so we are going to use a dilute. We are going to use a dilute from base. So this is what makes them different. And so what actually really makes them different is that in E, the base is concentrated, and in G, the base is dilute. And the last question is, name the type of elimination reaction represented by E. So let us go to reaction E. Right. Now, when you look at reaction E, bromoethane is being converted to ethene. Now, let us do that reaction. So we have bromoethane. Take a different colored pen. This one. There is bromoethane. We know this one because we've already drawn it. Bromoethane. And they are telling us that bromoethane is being converted to ethene. So this is our ethene. And there's the ethene. Right. Now, not everything has been shown here, my dear learners, altogether. Now, I just want us, we won't focus on conditions for this one for now, but what I want you to check here, my dear learners, is what is the transformation that actually happened? Can you see on this molecule now? This H is gone and this Br is gone. They were there. They were there. All together. So the H has been removed from the molecule. The Br has also been removed from the molecule. In other words, I removed the hydrogen and I also removed a halogen. And if I have done that, it means the type of elimination must be dehydrohalogenation. Must be dehydrohalogenation. Right. Why dehydrohalogenation, my dear learners? Because D, to show that I have removed hydro, show that I removed a hydrogen, halogenation, to show that I have removed a halogen. So it becomes dehydrohalogenation. And for that, I'm also going to get a mark. So the essence of this lesson, my dear learners, was to say, if you are given a flow diagram, you are supposed to interpret it. You must know that there will be other reactants that have been shown and others that have not been shown. There will be products that have been shown and those that have not been shown. And also the conditions, sometimes they can show them, sometimes they don't show them. So where a reactant or a product or a condition has not been shown, you must then work out that particular reaction altogether so that you can see if there is any molecule that has been omitted altogether. Right. On that note, my dear learners, I just want to remind you once more that this topic is very critical. This section on organic reactions It's about 18 to 20 marks, and you need to excel on that one. And once you do very well in organic chemistry, my dear learners, you are well on your way to getting a distinction, because this topic carries a lot of marks. Thank you so much for tuning in. Your hard work will eventually pay off. Enjoy the rest of the Saturday, and thank you for tuning in. I'm going to see you next week. Goodbye.